Okay, good evening, class. I want us to continue with the centroid of a body. Um, this is going to be from chapter 6, and then we're going to delve into chapter 11 as well. Okay, it's very important that we understand how to perform the centroid of a particular body because that's going to be needed when we dive into chapter 11. Okay. So as a recap, um, I just wanted to highlight here when you have a semicircle of this nature, how do you calculate the area? How do you calculate the centroid of that semicircle? And we'll talk about the moment of inertia as time goes on. Okay, we actually visit that in EGT 231. Okay, likewise, I would like to bring your attention to the um, this shape here, the isosceles triangle, and how would you calculate the centroid of this particular triangle. And here's the formula for the centroid. Again, this is for the semicircle, and this is for our area, respectively. Okay, and these are some examples of how to calculate um, the area and the centroid. Okay, the y bar. Okay, so let's move forward and really look at an example here. We have this shape, this geometric shape here, and it comprises of three different shapes. Also, it comprises of a solid and a hollow. Okay, so as a solution, again, I'm just briefly just kind of draw this if I can. Okay, looks something like this. Okay, and I am going to use right here is going to be 3, 2, 2, and 3. Okay, and here is going to be 11, while here is going to be 4. And these are all in inches, as you can see from the image up top. Okay, and we have a radius, r equals 3 here. Okay, and we're asked to find the centroid. Okay, this is what we're trying to find right here. Okay, so in other words, what you can do is, again, you want to have a reference line where everything comes off from, or everything is being dimensioned from here. So this is your, what you know as your reference line. Okay, so the idea is that you have a solid. If I break this up, you have a solid, right, which happens to, this is a rectangle which happens to be a solid, and you have a triangle which happens to be a void because it's a hollow space. Space right here is hollow. And then you have another one whereby it's a semicircle, is also hollow. This is also a void. Okay, so each one of these geometric shapes have a centroid. Okay, and we want to be able to find that. So we know, given our dimensions here, right, this is going to, we call this C1, and the centroid for this particular shape is just nothing more than our y1 bar equals h over 2, which happens to be 11 over 2 equals 5.5 inches. Okay, so that's for That's for Y1. Okay. So our Y1 here, 5.5 inches. Okay. And I can move this over a little bit. Okay. So now we know that this triangle has a height of 4 inches, right? Okay, and has a base of 4. Okay, so now we know that the y2 bar happens to be h over 3, according to our according to our formula right here, h over 3, right? So that's going to be 4 over 3. Okay, so I'm just going to erase this part so we can have some space. So our y2 is going to be around here. Y2 bar equals 4 over 3 inches. Okay, now this semicircle, right, it's located 8 inches from this reference line. Okay, and we know that, let me just kind of exaggerate this drawing a little bit here so we can, let me come here. Okay, so according to our formula, the centroid comes from the centroid is measured really from this flat end to a distance, a specified distance, that y bar, and that y bar is governed by this equation right here. So it will be the same thing here. Okay, this is 4r over 3 pi. So the question is, we want to be able to know this distance here. We need to go, so we're going from 8, from this reference line, we go up 8 units. We get to this arc, that's where the radius begins, right? And we have to know pretty much from here, from this centerpiece, we have to know this distance right here. Because that's where the centroid is located. So that's a place, that's a variable we don't know. And so what we can do really is, we do know that our x really is going to be nothing more than the radius is 3 minus the 4r over 3 pi, right? And that's going to give you a number, okay? But that whole idea is you have to be able to add whatever your x is, you have to add that to 8. So what that number is, let's just say for our calculator, this is going to be 4 times 3, which is r is a radius, 4 times 3. We're going to divide that by 3 pi. Okay, and we want to be able to subtract that from 3. So we have 1.726 inches. So, but we have to travel a distance of 8 though to get to that distance. So that's going to be 8 plus 1.726, which happens to be 9.726 inches. Okay, so your y bar, in this case, I'm going to erase this part. Your y bar here is going to be y bar 3 equals 8 plus 1.726 inches equals 9.726 inches. That's y bar 3. Okay, and let me just get rid of this part. so we can have some room here. Okay. Now once we found the centroid for all three geometric shapes, now our next step is to draw a table. Okay. Have it. So this is going to be our. Let me just move this down a little bit more. It's going to be our shape. Okay. And here is going to be, it's going to be a solid here, which is going to look like this. Then we have our void, which is going to be a triangle. And then we're going to have another void, which happens to be a semicircle. Okay. And then we can just populate each segment. So this is the shape. This is going to be our area, right, for each individual geometric shape. That's what that I means. So that would be, I means like a counter, 1, 2, and 3. And that's going to be inch squared. We have our distance, our centroidal distance, and that's in inches. And then we have the product of the area and the centroidal distance, AIYI, that's inch cubed. Okay. So the area of this solid is going to be 11 by 10, right? Okay, because this right here is going to be, this is 10. 3 plus 2 plus 2 plus 3 is 10. And this right here happens to be 11. So the area is 10 by 11, which is 110. Okay. Okay. And the Y1, Y bar 1 happens to be 5.5. And when you have the product of the two, you're going to get 605. Okay. Now for the triangle, this is our triangle here. Our Y bar was 1.33 inches, because 4 divided by 3 is 1.33. I'm sorry, I have that in the wrong location. It's going to be 1.33. The area of a triangle is nothing more than 1/2 the base times the height. Where the base is 4, the height is 4. Therefore, your area is going to be 8. But keep in mind, you want to put a minus because it's a void. Okay. Now the next thing we have to do, we have to take the product of the two, and that's going to be negative 10.666. Okay. Our next geometric shape is a semicircle. It's also void, and the area of a semicircle is nothing more than pi r squared divided by 2. And you find that here as well. This is the area of a semicircle. Okay. So when you do that, you're going to get pi, the radius is 3 squared divided by 2. And that's going to give you negative 14.13. Again, it's a negative because it's a void. Okay. We find out uh, what our y bar 3 is, right? And that's going to be 9.726 inches. Multiply the two together, and you're going to get a negative 137.43. Okay. Now you typically want to just take the summation of the areas. You're going to get here 87.87. You do nothing to the distances, and then you take the area of this last column, and you should get 456.904. Now when you want to find the total centroid of all these different shapes together, it's going to be the summation of the of your area, the product of your area and your distance, your centroidal distance for each geometric shape. Divide that by the summation of the area of each geometric shape, and that's going to be 456.904. divide that by 87.87, and your Y bar happens to be 5.2 inches. Okay. Okay, I'm gonna stop here. I hope this helps. And we will continue later. Thank you very much.